Hello everyone. Welcome to another video of Inside Science and Creative Technologies. In this video, we are going to learn about a KNN classifier. So, starting with the video, now we have a question that why do we need a KNN? What is the reason for using a KNN as a classifier? So it can be explained by giving some background knowledge about machine learning. So, the concept of machine learning is to teach computers how to learn and improve using past experience instead of being programmed by humans themselves. Machine learning models try to accurately make predictions by learning from past data which is available in the form of a dataset. We give an input to the machine learning model and the model will predict the output to the respective input. Where the machine learning model is trained by giving data from a set of dataset. Let's take a simple example of a child who is looking at a cat and asks his mother whether it is a cat or a dog. Mother tells the child that you can identify between cat and a dog by their features. Cats have sharp claws, small ears, they meow and purr and do not like to play. But dogs have dull claws, big ears, like to play a lot. Now, if a child looks at a dog or a cat, he or she can easily look at the features of an animal and predict the output. Machine learning algorithm trains the computer in the same way. Training from input data from dataset and predicting the feature input is its role. When teaching this to a computer, we need classification to be playing its role. When a new input is given to a computer to predict its correct output label, machine learning model requires a way through which it can find out whether it is a cat or a dog. Here we need classification. Classification is used to categorize a dataset into classes. Its purpose is to recognize data from dataset and separate the data into classes. A classification algorithm will be used to categorize vast amount of data from a dataset. For classification, we need a classifier like KNN. Now, we can have supervised learning as well as unsupervised learning, about which we have discussed in detail in sport vector machine video. But giving a slight intro, in supervised learning, we train a machine learning model by using a labeled data from a dataset, and trained machine learning model will then predict the accurate output when an unlabeled input is given to it. So, think of a computer as a child. We are its supervisor. You can say we are its teachers or guardians. And we want the computer, which is a child, to learn what a lion looks like. We will show various lion pictures to the computer or child and other animal pictures as well, so that he can be capable of differentiating both the features. Now, after showing hundreds of pictures of animals including lion, horses, cats and dogs to a child, when we show a picture to test whether a child or a computer can predict what kind of animal is in the picture, he will predict correctly if the animal in the picture is the animal in the picture a lion or a dog or a cat or a rat or anything else. This is supervised learning. So KNN is a supervised learning model, but however KNN is capable of doing unsupervised learning as well. So we need to keep this thing in mind. KNN can be used for classification as well as regression purpose, but in this video we are just going to cover KNN as a classification model. So what is KNN? As KNN is based on feature similarity, then we can do classification using KNN. Input image of a cat goes into a trained model and then the model predicts the output as cat images. By input image, I mean the feature extracted by the feature extractor algorithm from the input image. K nearest neighbor is a supervised learning algorithm using for mainly classification, which means when given an input to a trained model, we want to know whether the input image is a cat or a dog. So the question arises that how KNN classifies. It classifies a data point based on how its neighbors are classified. So that is the problem statement for KNN classification. Here we have a data set with non-classes. Here we have an example. Now, what we used to do in SVM is that we used to make a hyperplane, right? We used to draw the hyperplane so that we can classify the two classes. Like the hyperplane used, if it will be have been SVM, we used to make this hyperplane and we used to resolve the classification problem using it. But now, supposing that we have some other sort of problem over here. We have this particular sample being made available in our data set. Now, what we are going to do with this? Now, here is a problem. That's where the KNN plays its role. Now, we have a new cell with unknown class. We want to classify this new cell and figure out to which class this cell belongs. So that's something complicated when it comes to SVM, because this particular sample, we can say that this wasn't available during the training procedure, but when we move towards testing procedure, or it was being used in practical life, so such a sample occurred. So what we are going to do in that case, you can have 3 or more classes of data. There, you have to classify the new point by looking at the nearest neighbors. We classify the new data point or cell by looking at the nearest neighbors. Now, that's what, and that's how the role is being played by KNN. Supposedly, we have a new cell over here. Obviously, we are very much sure that it doesn't belongs to class 3. We can very much see from here, over here, it doesn't belong to class 3. It belongs to, the new cell belongs to either class 1 or class 2, but we need to classify it that to which particular class it belongs to. So we classify the new data point or cell by looking at the nearest neighbor in the case of k and k nearest neighbor. In the first step, we select the k value, mean how many nearest neighbors are we going to consider. Example, k is equals to 4. So right, so that is how it plays a role. If k is equals to 4, we will use 4 nearest neighbors. To find the 4 nearest neighbors to our new point or cell, we calculate Euclidean distance between the data points and our new point or cell. Pick 4 nearest neighbors with least distance with our new point or cell. So now we'll look for find how many nearest neighbors belong to either class. Now that is also one of the research problem, that how we are going to see that how many neighbors we need to consider. In this case, where k is equals to 4, 3 nearest neighbor belongs to class 1 and 2 nearest neighbor belongs to class 2, right? So keeping this example, now 2 to class 2, 3 to class 1. Now where class 3 is of no question because it was completely different, so where the new cell belongs to. So now the question over here is that how do we pick the class of our new point or cell? we simply choose the class which has the maximum number of votes. Now here we are going to have a majority voting. So you can say that in KNN it's all democracy. So in this situation, three neighbors are are belonging to class 1 and two nearest neighbors are belonging to class 2. Since class 1 has 3 votes as compared to class 2, so we choose that this particular new cell belongs to class 1. So meaning our new point is now categorized as class 1. So there are no defined rules to select the value of k. Now that is something very weird in k nearest neighbor problem. We may have to try few different k values before choosing the best k value. We can have like we can keep on changing the k values and get the most optimized value for the particular problem. Every problem is going to have different k value, so we cannot say that there is no particular algorithm being designed for selecting the k value so far. So this is all about hit and trial method. But consider this while choosing the value of k. Three major things we have to consider. The first one is small value of k can cause confusion and can cause our new data point or cell to be affected by the outliers. Remember we discussed about the outliers in SVM video. So outliers is a big problem in machine learning. So we need to keep care about this, that it k shouldn't be of small value. Larger values of k do not select k value too large that a particular category with large number of point can nullify the effect of each category points. So it shouldn't be too large, it shouldn't be too small. So most used value of k so far seen is k is equals to 5. And many of the research algorithms for different data sets have identified k is equals to 5 is the optimized value. But then again, we cannot say that this is 100% for sure, because with the change of data, even k is equals to 5 has been seen to be failed. One most used way of choosing k is choose k which is as a square root of n. Here we can see our equation as well. All right, so it should be k. No, I can write over here as well that k should be equal to square root of n. Now what is n? N is the data points. The data points or the values that are being made available from the feature vector. So we are going to use that value. One more thing, while we are doing different experiments, what we can do is we can keep the k value to be differentiating. Like this can be one of the experiment in the research, that for getting the optimized value, let's suppose over here I had you can say the value of n for this particular was 9, right? There were 9 data points, so obviously I will be having 3. So meaning the k value might be, it can be 3, right? So what I can do is I can keep the value 1, 3, 5, 7, 9, all odd values, and I will be very much looking into the change of the pattern of the accuracy while changing the value of k, and that can give me a good solution towards optimizing the k value for the particular data set. So if we have data belonging to two classes, class 1 and class 2, we choose odd value of k, which is to vary the value with the odd numbers. I think that is all with the k nearest neighbor working principle. I hope you like the video. Do like, share, and subscribe the channel, and hit the bell icon so that you can get update when a new informative video is being made available. Thank you so much for your time.